greetings to all of you. In today's session, we are going to start with the chemistry on the international floor if you are preparing for any entrance or competitive examination as well. In the national level, JEE Advanced, JEE Mains exam, NEET medicinal entrance examination, Telangana and Andhra Pradesh EAMCET exam for the engineering entrance. In addition to all these, if you are aspiring for any government jobs, in that case also this kind of explanation will be very much helpful. Let's enter into our today's session. The question number 1 starts with the IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry. Name the following compound as per the IUPAC protocol. This is the compound provided we need to assign its IUPAC nomenclature, right? Where we have benzene ring and CH2, CH, NH2, COOH will be there. In general words, we can say it is called alpha amino acid. Alpha amino acid is the kind of starting material in order to synthesize a protein. It is the monomer for the synthesis of protein in the polypeptide chain formation, right? We are going to assign name for this compound, this organic compound as per IUPAC regulations, right? So right answer will be 2-amino-3-phenyl propanoic acid. This will be the right representation for the given organic compound. Let's see how can we explain this one. As per the IUPAC regulations, carboxylic acid can be given as carboxy if prefix. That means if we are taking as a substituent, that can be taken as the carboxy. But most of the cases, carboxylic acid being it is the highly oxidized one, will get the higher priority in the given organic chain, so that the suffix will be taken as the oic acid. We can say alkanoic acid. The entire root word will be a alkanoic acid for the carboxylic acids. Fine. Carboxylic acid can only be represented with one carbon. Then if only one carbon is there in the carbon skeleton, need not to mention one, because if only one is there, so we can't say one apple is there. So an apple is there. That's in that way we can explain. No, in the same way, if only one carbon, need not to mention that one, right? And moreover, there is a difference between the phenyl and benzene. Phenyl is represented with less one hydrogen. Benzene is represented with C6H6. If all the what we can say hexagon corners occupied by the hydrogen, 6 carbons will be occupied by the 6 hydrogens called benzene, and 6 carbons accompanied by only 5 hydrogen atoms, that is said to be phenyl. So that we can't say benzene. Somewhere it is mentioned as benzene, so that we can omit this. Always this is the kind where we have C6H5, hence the phenyl is the right representation. And moreover, the carbon of carboxylic acid to be taken into the consideration for numbering. It can be taken as a 1, and here it will be 2. On second carbon you can find amino, and on third carbon phenyl will be there. Fine. So that the right representation will be on the second carbon amino is there, third carbon phenyl is there. As per the alphabetical order, amine comes first over phenyl, because A will be first over P. That's the reason why let me mention 2-amino-3-phenyl propanoic acid. This will be right representation, because it is the kind of 3 carbon chain, 3 carbon taken as the parent chain, and on third carbon you can find phenyl, on second carbon we have amino, and first carbon carboxylic acid is there. So that the entire naming will be 2-amino-3-phenyl propanoic acid. For question number 1, option number C will be the correct answer. Move on to question number 2. Question number 2 is given from Cambridge Assessment International Education. Here, the complete combustion of propane is exothermic. Exothermic means heat evolved during the reaction. The equation for this reaction is given by propane being 3 carbon chain, C3H8 will be there. Combustion is exothermic. Oxidation in the presence of excess heat is called combustion, so that it converted into carbon dioxide and water. Which energy level diagram represent the complete combustion of propane? These many graphical representations are there. Among all these graphical representations, what will be the right order? So in order to explain that one, always the reactant should be taken on the left hand side so that we can exclude this. There is a possibility for option number B. Option number D also having the possibility. Option number C also excluded, because the left hand side, moreover, we have to consider reactant molecules, not products, so that AC may not be correct. And in case of B, you can find C3H8, 5O2 molecules are taken, and this is at the bottom. And where you can find these products are released over here. So these released products are represented at the topmost region, which is saying that they are accompanied by the higher energy. This is the energy coordinate. We can say this is the energy coordinate. No, on this energy coordinate, these reactants are laying at the bottom and the products are laying at the topmost region. And they gave one hint called exothermic. Exothermic means heat evolved. Whenever they are releasing heat, their energy got fallen. So higher energy may not accompanied by the product molecule. So the right representation will be option number D. Progress of the reaction can be taken on X coordinate, energy taken on Y coordinate, reactants on the left hand side, products on the right side. On the energy comparison, product of less energy compared to reactant being it is exothermic in nature. Let's see the clear description. This is the kind of representation where you can see combustion of propane with oxygen, carbon dioxide and water generated on this combustion graph, and wherever curvature of peak you can see, that is called transition state. And exothermic reaction, always during the combustion heat is given up. So you can see arrows are represented out of the sphere, so that it is the kind of exothermic reaction. Fine. And the normal combustion graph is mentioned over here. And combustion stands for burning of any substance in the presence of excess of oxygen is said to be a combustion. And this is the way you can represent a normal combustion graph. Always product should contain lower energy in comparison with the starting material, being it is exothermic reaction. Heat evolved can be represented over here. That's the reason why the right order for the given question. For question number 2, right answer will be option number D. Option number D will be the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2023 question paper. A solution is prepared by mixing 0.01 moles of each what we can say carbonic acid, and this is said to be sodium bicarbonate, and this is called sodium carbonate, and sodium hydroxide. If you see, carbonic acid is the acid, sodium bicarbonate is the mild base, sodium carbonate is the strong base, sodium hydroxide also the strong base. These many compounds got mixed. Upon mixing of all these in 100 ml of water, pH of resulting solution. So here various nature you can clearly observe. Some are mild, some are strong, some are acid, some are bases. If we mix up all these in a 100 ml of water solution, what will be the resulting pH we need to identify? In order to find out this one, here pKa values and pKb values are provided. pKa value and pKa value for what we can say carbonic acid is given by 6.37. pKb value is given as a 10.32. So this is for what we can say strength of acid, and B for strength of base you can clearly represent. And log 2 value is also always constant, that is 0.32. By using this data, we need to find out, we need to solve the given problem. Okay, answer is expected to be 10.02. How can we get 10.02? Let's enter. Right, so the reaction carried, though these many are present, what you can say sodium bicarbonate, sodium carbonate are said to be salts, no? So that the reaction directly carried in between acid and base. Carbonic acid is the acid and sodium hydroxide is the base. Direct reaction is possible among these two. So that neutralization could be carried over here. And you can see, sorry for a minute. What we can see, it is the kind of neutralization reaction where sodium hydroxide and carbonic acid when mixed, sodium bicarbonate and water will be formed. This is said to be a kind of neutralization. Fine. So resultant mixture will be sodium bicarbonate and sodium carbonate as well. Whenever sodium bicarbonate is there, let's go back. Sodium bicarbonate is there 0.01 molar. the sodium carbonate is there, 0.01 molar, which is already there in the solution, that is 0.01. Within the solution, we have sodium bicarbonate, that is 0.01, and one more mole is generated during the chemical reaction, second mole. So that's 0.1 mole given solution, 0.1 mole which is generated within the reaction, so that it will become 0.02. Hope you can understand what we are explaining over here, right? So here, all the mixture solutions are having 0.01 molar concentration, where sodium bicarbonate already exists to 0.01. Sodium carbonate also exists to 0.01. But whenever carbonic acid and sodium hydroxide got mixed, there is one more new sodium bicarbonate got formed, so that we can say it is one more 0.01 mole. So it is a 0.02, 0.01 for sodium carbonate, sodium bicarbonate 0.02. And we have to give the definition for buffer solution. Any buffer will be the strong base and it's a salt with a weak acid. Okay, this will be called as a strong base and it's a salt with the weak acid. Okay, so this mixture said to be basic buffer solution. Basic buffer solution is given over here. The mixture is said to be basic buffer. Then in order to calculate the pH of the solution, we have the equation called Henderson equation. pH is equal to pKa plus log 0.01 by 0.02. Right? So pKa plus log 0.01 by 0.02, which is taken as pKa value is already known to you. pKa value is a 6.37 value, and PKB value is 10.32 is provided. 10.32 will be taken, minus of log 0.01 by 0.02. If you calculate this one, what happens? It will become log log 1 by 2. So if plus log 1 by 2 is there, if you want to take this denominator into numerator, we can change it. It's a sign convention. It will become minus of log 2, right? Minus 10.32 minus log 2. Log 2 value also known here, that is 0.30, right? So if you substitute that value, final one will be 0.02, because here you have 0.32, no? So subtracting this one, 10.02 will be the value whichever given in the answer. Right, this is the way we can solve. Though we have mixture of solutions, we have to substitute in the given equation. Here buffer solution pH formula is provided. Buffer solution pH formula is equal to pKa plus log, what we can say, this is called what? Base by its salt. Base by its salt can be taken. Right, for question number 3, 10.02 will be the resulting pH of the solution. Okay, move on to question number 4. The treatment of aqueous solution of 3.74 grams of copper nitrate with excess of potassium iodide results in the brown color solution along with the formation of precipitate. Okay, so here when we are treating all these, what we have to identify? Amount of sulfur to be reduced. How much amount of HTS consumed can be reduced. Okay, so treatment of aqueous solution of 3.74 grams of copper nitrate. It is the weight of copper nitrate, and this is titrated against potassium iodide. Whenever copper plus 2 is titrated against potassium iodide, copper plus 2 is converted into copper plus 1. This is called cuprous iodide. Cupric is converted into cuprous. Okay, plus 2 to plus 1 is called what? Reduction. And here I minus is there, which converted into I2. Minus 1 is converted into 0. Always increasing the oxidation number is said to be oxidation. Hence, this together is said to be a redox reaction. Copper got reduced, iodide got oxidized. Okay, and this is the reaction said to be iodometry, where estimation of copper we can say. Fine. And whatever iodine liberated in the reaction can be titrated against H2S. H2S is the gaseous component we can say. And H2S, when treated with this one, there is a formation of HI. HI will be generated and sulfur will be liberated over here. sulfur will be liberated. Okay, there is a equivalence, we can say. Copper nitrate, how many copper nitrate moles we are using, that equals to equivalence of sulfur, because estimation, we are not directly estimating copper, rather we are indirectly. This is said to be an indirect estimation process. Why it is called indirect estimation? Copper treated with iodine, copper not directly treated with H2S, no, but we are relating copper with sulfur. How? In the indirect manner. Equivalent of copper is equal to equivalent of sulfur, we are saying, because copper reacted with iodide and subsequently that released iodine can be treated with H2S. It is the kind of indirect correlation between these two substances. And there is a formation of sulfur in addition to 2 moles of Hi. Fine. And here N1 moles of iodine is same in the both. So whatever number of moles of iodine liberated and consumed exactly same, so that we can compensate. Here copper plus 2 is treated and there is extent of sulfur is generated. So that equivalent of copper nitrate is equal to equivalent of sulfur, we can take the equation. Okay, for that purpose, you may take weight by gram molecular weight into number of moles, weight by gram molecular weight into number of moles. Weight of copper nitrate is given as 3.74. Molecular weight of copper nitrate is 187. Number of moles taken 1. Equivalent of sulfur is to be determined. Weight of the sulfur is not known to you. You need to estimate this one. What atomic weight of sulfur is, atomic number of sulfur is 16. We can multiply so that its atomic weight is given, that is 32. And number of moles participated will be 2. Right. So if you calculate all the known terms, it is obvious to calculate the X, that is the weight of sulfur given in the equation, that is calculated as 0.32 grams. It is the called volumetric estimation, and it comes under redox reaction and a part of iodometry, where brown color solution will be generated as the precipitate. The precipitation will be a brown color in nature. This is the way we can answer. For question number 4, 0.32 grams will be the right answer. Move on to question number 5. This is the question collected from the competitive examination conducted by Telangana government. The ion which is not in tetrahedral structure is, tetrahedral geometry is not acquired by which of the component? Boron tetrafluoride anion, NH ammonium cation, copper tetramine dication, nickel tetrachloride dianion. These many compounds are there among all, which will not be the tetrahedral. We have to identify. BF4 is said to be, BF3 is a kind of sp2 hybridized and trigonal planar. Whenever BF4 minus is there, that is called what? That is called a tetrahedral ion. We have one negatively charged ion. Purely it is the tetrahedral. What we have to identify? Non-tetrahedral compound we need. So another one is ammonium. Ammonium chloride, where nitrogen is surrounded by 4 hydrogen atoms with the positive charge, so that ammonium is also not a tetrahedral one. And go to the copper. If you go to copper, always remember, so in that copper family, what we have? Copper, palladium, platinum. Copper complexes, palladium complexes, platinum complexes in general are square planar in nature, so that you can clearly assume that copper, NH3, 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 NH3 all are laying in the same plane, and it is the dipositive cation, right? Sorry. And another compound is nickel tetrachloride -2. So this is also tetrahedral. Among all are tetrahedral compounds only except copper tetramine. So copper tetramine is the square planar compound. For question number 5, option number 3 will be the correct answer. Move on to question number 6. Which one is colorless compound among the following? Colorless compound we have to identify. Colorless compound in the sense, so always remember, D block elements, all the D block elements are used to give the intense colored compounds. So many colored compounds are available for D block elements. So many various valencies also available. That's why we can use D block elements as the catalyst. excellent catalyst in the industry. Okay, so these are the applications of D block elements, but few exceptions are there. Some of the compounds are colorless in nature. In order to explain about what is the reason for colorless, first of all we have to know why they exhibit colors, then only we can go for why they are colorless. Okay, D block elements in general used to give the intense colored compounds because of two reasons. One is due to D-D transition. Second is due to charge transfer spectrum. D-D transition stands for lower d orbital electrons when propagated to the higher d orbital electrons. So that what happens, excitation of electrons, and from excited to ground state, what happens, some extent of energy will be released, no, so that they will exhibit colors. Okay, that is called DD transition. And charge transfer spectra, charge transfer in the sense either metal to ligand or ligand to metal charge transfer is possible. In that case also intensified colors we can see. Okay, but some of the compounds are said to be colorless as well. Okay, here you can see vanadium complex, here also vanadium, here also vanadium, here also vanadium. All the complexes are said to be vanadium only, but among all one only is said to be colorless in nature. And why we need to explain. In order to explain that one, first of all we have to know VCl5, vanadium pentachloride, we can say. Vanadium pentachloride exhibiting trigonal bipyramidal geometry. This is called what? Trigonal bipyramidal geometry. 3 chlorine atoms are laying in the equatorial position. 2 chlorine atoms are laying in the axial position, above of the plane and below of the plane. So that it is called trigonal bipyramidal geometry. Okay, so this is the general representation. And if you see, the vanadium atomic number is 23 and it contains 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. If you observe the valency shell, these two are said to be a valency shell, and they are responsible for the bond formation. S orbital is having 2 electrons and d orbital also having 3 electrons. So total valency electrons are 5. These 5 electrons lost during this vanadium pentachloride formation, because here vanadium is occupying vanadium plus 5. If you see the oxidation state around the central metal, that will be vanadium plus 5. Vanadium plus 5 acquiring the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d0, sorry, 3d0. 4s0, 3d0. That means outer electrons, 4s2, 3d3 electrons totally lost. 5 electrons when lost, then vanadium plus 5 oxidation state around the central metal you can notice over here. Right. Whenever d orbital electrons are absent, whenever d transitions are possible like this, any d electron is migrating from lower energy level to higher energy level, they able to exhibit such kind of colored compounds. So many colors are possible. Different colors are observed for the different kind of compounds. If you take the chromium, that exists in orange color, manganese complexes are purple in color, nickel complexes are green in color. In this manner, so many intense colors are possible for d block elements. Okay, that is due to DD transitions. But whenever D0, no electrons are there in the d orbital, what happens? No transition, no d electrons means can we migrate electrons from T2G to EG? There is no possibility. Hence we can say DD transitions are absent, so that the compound is said to be a colorless one. Colorless is nothing but like this. Okay, so this is the way we can clearly observe vanadium Cl5. Vanadium Cl5, if you observe, there is no d electrons present. That's the reason why no dd transition. Hence, we can say it is the colorless complex. For question number 6, option number 2 will be the correct answer. By this, we entirely completed the session and the detailed explanation is provided to you. Hope this will be helpful for your preparation. And I am sincerely requesting to like the channel and comment which part is really interested and really important for you. And share with the aspirants who are seriously preparing for the examinations. And subscribe the channel in order to get more such updates in the near future. And thank you very much for your patient listening. Thank you one and all.